Hey everybody. So for this quick video, I wanted to talk about vectors, which we'll be doing in the lab activity. And again, the first 2 weeks of lab this term are purely online. After that, I will start holding in-class labs, in-person labs, but you'll have the option to keep doing the online simulations or attend the in-person lab. But I wanted to talk about vectors. So first of all, we have two types of quantities that we're going to deal with in physics. Now, what is a quantity? Well, a quantity is something that can be measured. For example, the mass of an object, it's something that can be measured. The weight. We can measure how fast you're driving along the road. That's something called velocity, right? We can measure things like acceleration that we will end up defining in greater detail later on. But the two types of quantities are vectors and scalars. Scalar quantities are pretty simple. They are just numbers. Now they have a unit associated with them, right? Because we have to agree on the units that we're using so that we can compare different measurements or what we're talking about. So for example, when I talk about the mass of an object, I will say 5 kilograms. That's all I need to describe it, a number with a unit. Other scalar quantities, for example, are temperature, right? I say 70 degrees Fahrenheit. I don't say 70 degrees Fahrenheit to the west or to the east. So scalars do not have a direction. Vectors, on the other hand, do have both a magnitude and a direction, right? So if you're driving in your car at 50 miles per hour, you really are only giving the speed. The speed is the magnitude, right? Just the number and the unit. And it is kind of just the magnitude of the velocity vector. So velocity is a vector quantity. I would say 50 miles per hour at whatever direction you're going, right? 50 miles per hour to the east, 30 degrees north of east, whatever the direction is, to fully describe that vector quantity, I need to give the magnitude, 50 miles per hour, and the direction, 30 degrees north of east. Now, you can read more about vectors and stuff in the textbook, but what I wanted to talk about for this video is basically how do you deal mathematically with vectors? And also maybe show you a brief introduction to the lab simulation. So when we talk about vectors, we need a magnitude and a direction. So I'm just going to speak generally mathematically. And let me share my screen here. So what I've drawn here are a couple of vectors. This is vector A, and I represent it by an arrow. Now, if I'm doing everything to scale, I would need a ruler and a protractor, right, to tell me the correct angle or correct direction. But just roughly speaking, I can draw it or represent it with an arrow. Now, if I had a vector twice as long, I'd make the arrow twice as long. But I'm going to call it vector A. It could be any vector quantity, velocity. Turns out acceleration is a vector quantity. So there are a lot of vector quantities we will come across throughout the whole year of physics. So understanding how to deal with vectors is very important. So I've got a vector A kind of going this way and a vector B going that way. And what I have described these vectors in terms of are their components. Instead of saying the angle, right, and the length of the vector, I could also give the x component and the y component. And basically, I set those up so they are perpendicular to one another. So this is a 90-degree angle. It's kind of like making a right triangle with the vector as the hypotenuse. Now, so this x component, I label ax, is 5 units long. If it's a velocity, it would be 5 meters per second, whereas ay is 10. All right, and I've got a second vector here, b, and it has an x component of -3, right, because it's kind of going this way, and a y component of -5. It kind of goes down and then to the left. So those are my x and y components for vector b. We'll talk about how to get those components if you know the angle and the length or the magnitude of the vector in a minute. But what I want to emphasize is once I have these components of the two vectors, how do I add the vectors together? It's very simple. If you look at it, right, the x components are completely independent of the y components. They don't depend on each other because they're perpendicular. So what I can do is I can get the components of the new vector, the sum of a and b, by just adding the x components together separately. So I get 5 plus negative 3 in the x direction, and then doing the same thing for the y components, adding them up separately in the y direction. So I get 10 plus negative 5 for my new y direction component. Now there's a special notation you'll often see when dealing with vectors called unit vector notation. It's really just a simple notation to indicate which is the x and which is the y component. So the way I'd write this is, let's say my new vector I call c, and it's equal to a plus b. Well, 5 plus negative 3 is 2, so I have 2 for my x component. I just put an I with a hat, or I hat, next to it. This tells me that it is the x component. For the y component, I get 10 plus negative 5, or 5, and I put a j with a hat next to it. All right, so it's really just a notation to tell me that I've got 2 units in the x direction and 5 in the y direction. There are other notations. Some people just use an x with a hat and a y with a hat. So it's really just a simple notation to tell me, right, which one's the x and which one's the y component. So now if I drew my vector, I would draw my x component for vector c going over 2 and my y component going up 5. Then the question might be, well, let's say I wanted to know the length or the magnitude of this vector. Well, now I can just use trigonometry, right? I mean, it's a right triangle, and the length or magnitude of c is the hypotenuse. The sides are 2 and 5. So just use Pythagoras' theorem, right? C squared equals cx squared plus cy squared. Well, I take the square root to get the actual length of c, which sometimes I'll kind of put sort of an absolute value symbol on, but this represents the magnitude of the vector, right? It's not magnitude and direction, it's just the length. Well, plugging in my x squared is 4, my y squared is 5, so I get 4 plus 25. That gives me square root of 29. I get 5.39, or about 5.4 would be the length or the hypotenuse of that vector c. Right, so I can go back and forth between my component method and my sort of length and direction, because I could also get this angle, let's call it theta. If I again just use a little more trigonometry, right? Tangent of theta is opposite over adjacent, or 5 over 2. So solve for theta, inverse tangent of 5 over 2, I get 68.2 degrees. Now be careful you're using degrees, you know, you have the right mode in your calculator, but this is just basic trigonometry. You can go back and forth between components and length and direction. Now, what if you wanted to subtract? Let's say I took a minus b. Well, that's pretty simple. Instead of adding the components, like I did up above, right, 5 plus negative 3, I subtract 5 minus negative 3. And so I will get different components when I subtract the two vectors, and that will give me my new vector I get from a minus b. Now, before I do one more complicated problem, sometimes you will be given, you know, 5.4 and 68.2 degrees. How do you get the components? Well, think about your trigonometry. Cx is going to equal the magnitude of c times the cosine of theta. Right? It's the adjacent side, so I just multiply the hypotenuse times the cosine to get the x component here, or the adjacent side really, and I multiply by the sine of theta to get the opposite side, the y component in this case. So again, it's all trigonometry, but you'll often come across cases where you need to go either way. Start with the components and get the length, or start with the length and get the components. But this method of adding or subtracting vectors is called the component method. Now, it can have can happen that you may have more complicated situations. What if I had this? I want the vector C that is 2 times A minus 5 times B. Well, if you go back and look at your vectors, A and B, right, I have really 5I hat and 10J hat. That's my vector A. So I'm going to multiply it by 2. And I've got negative 3x hat and negative 5y hat. That's my vector B. I'm going to multiply it by negative 5. So I just basically distribute through with the 2. I get 10I hat plus 20j hat. Gives me this first term. Minus 5 times negative 3 is a positive 15I hat. And then I get a plus 25j hat. So I just, whenever I have scalar numbers multiplying a vector, you just multiply all the components. Now, one thing to keep in mind, when you do add vectors, you never add the I hat to the j hat. They are perpendicular to one another. They're x and y components. So I'm just going to take my 10I hat plus my 15j hat, and that gives me 25I hat. Add my j or y components together, 20 plus 25, I get 45j hat. So this is my new vector, and I could, draw out the components if I want. So that's a real quick sort of crash course in adding vectors using the component method. You'll probably have a lot of problems or number of problems or come across a lot of cases where you have to do all of this stuff. Now, other thing I wanted to share or talk about is the particular lab that this video is associated with. So let me share the screen of the simulation that I'm going to have you do. If you go into your lab section on Canvas and go into the assignments and look at lab 1, there will be a link to this PhET simulation, there's a bunch of these simulations at the University of Colorado. So if you go to this and you hit play, you will come across a vector simulation, a vector addition simulation. So let's go ahead and just look at this real quick. I think you can just go right into this lab part. And what you can do there is you've got your vectors here. I'm just going to take a couple of blue vectors. Right, this might be like my vector A. You could even set it to give you, whatever x and y components you want. Maybe I want to try to give 5 and 10. Right, so there's like my vector A. Now I can make a second vector, we'll call it B. I got to turn it around. So it had negative 5 in the y direction and negative 3 in the x. So there's my vector B that I had when I did it by hand here. Now if I want to get the sum by adding these two vectors together, there we go, right? And what I should find is that if I want to draw the components and check my math that I just did, I can hit this little button here, and I can see that my vector S does have components of 2 and 5. So this is just sort of a simulation to help you draw the vectors. Now, one thing to notice, let me take away the components. A way that you could draw or add vectors graphically is you can use what's called the tip-to-tail method. Let's see. Well, actually, I should say you can draw your components anywhere you want too, right? I mean, I could even draw them over on the axes here. This is my y component for vector A and my x component. I just usually draw them as the sides of the triangle here. I wanted to get rid of these components. Let's see. Well, that got rid of all my stuff here. So let me recreate my vectors, 5 and 10. And let's actually turn this around to negative 3 and 5. Okay, so one thing that you can do if you want to add vectors and you don't have the components, maybe you got a piece of paper and a ruler and a protractor is you can use what's called the tip to tail method. So what I would do is take my first vector, set it somewhere, and then move the second vector over and attach it to the tip of the first one. Now what will happen is that the sum vector will go from where you started to where you finished, right? So at the beginning of vector A to the end of vector B. So let's try that. Let's hit our sum. Now I'm going to move it, and you'll see that it will fit right in there. Goes from the beginning of vector A to the end of vector B. These are a little bit kind of aligned pretty well, so let me just do it real quick for a second set. Let's say I've got that vector. We'll take another vector here that goes like that. When I get the sum, it looks like that. Well, again, I would take my first vector, attach that to the tip of that, and you should see that this just goes from start to finish. So this is a graphical way, right? I mean, you could do this anytime if you had drawn everything to scale and measured everything out perfectly with your ruler and your angles with your protractor. But if you want to draw it roughly, it's a way of checking your component method mathematics and making sure that your math makes sense. Now, I should say other things about this simulation. Let's look at vector S. If I want to get the angle, I can do that. Again, I can draw the components. So in the lab, you'll have various questions about this simulation. And just answer those, write them on a separate piece of paper, and then upload them to Canvas, right? And that will be the lab for this first week. At the beginning of the lab session, I will be there if you have questions. I'm not going to make you come to the lab. You can do this on your own. If you want, or you do have questions, I would suggest that you come and talk to me about it though. So one last thing here, let's clear this. If you go, let's see, let's go back to what I had originally, to the original simulation. You could play with these other parts of it as well, but I wanted to show you this last part. There's an equations section, right? And so in this case, you've got vector A and B and C. And you can see up here, I've got 1A plus 1B equals C. So if I wanted to write an equation, I can actually change these numbers and you can add them together here, right? Now this is a little big. Let's just maybe do a little bit smaller. But you can see that you can, check that type of problem that I just did as a last example on the piece of paper here. So you can do a lot of different mathematics kind of simulations of vector addition, subtraction, and equations. So I'm going to stop there. Again, if you do have questions, you can show up at the lab time or shoot me an email or just let me know. We can set up a separate Zoom time if you really need some extra help with this stuff.